we thought it would be interesting to think about the way that technology was being brought to bear on many aspects of water. And so we have a session entitled Innovative Approaches to Water. In this session, we'll feature two Nobel laureates, Dan Shechtman, who is the 2011 Nobel laureate in chemistry for his discovery of quasi-crystals, and Konstantin Novoselov, 2010 laureate in physics, for his invention and discovery of graphene, the thinnest form of carbon. And also joining this panel will be Sawako Takeuchi, who you already met, Kumiko Oguma, and also our moderator, Yuko Fujigaki. So please join me in welcoming them on stage in a minute. I'm sorry, I'm going too fast for our organizers. But still, it's good to rest a second between topics. Okay, please, may I welcome my panelists on stage. Hello. So Yuko, if you'd sit over there. Kumiko there. Dan, you're in the middle. Sawako, you're here. Kostya there. Perfect.
Okay, thanks, Adam. Let us begin our session on innovative approach to water. As you noticed in previous sessions, water management is one of the key issues for designing sustainable future. At the same time, innovative approach to water is also important for designing the sustainable future. Okay, so for example, Professor Oguma is doing research on ultraviolet-based technologies to decompose contaminant in water, as well as ultraviolet disinfection of water. So, Professor Oguma, will you please explain about your research?
Okay, Professor Fujigaki, thank you for the kind introduction. And hi, everyone. This is Kumiko Oguma, the University of Tokyo, Japan. And as now just kindly introduced, I'm doing mostly the water treatment technology development and evaluation. And I'm based in engineering department, and that's how I'm very much interested in innovative technologies and how to use it to the real society, to the real world, to make the society much better in a safer place. So what I'm doing is to apply UV radiation to treat water, mostly focusing on the disinfection purposes, which means killing the microorganisms in water to make it safe to drink. So that's what I'm doing, just briefly, thank you.
Okay, thanks. So next, Professor Novoselov, you received Nobel Prize in Physics in 2010 for your research on graphene, right? And this is one of the new materials. So will you please tell us how innovative new materials can approach water management?
Right, it's because it's a big topic, and me being physicist, really, it's just I had to switch to material science, and then when you do it, you just realize how many more opportunities do we have with the innovative materials for a number of different applications, from electronics to composites. And of course, membrane technology is closely related to the topic of the two-dimensional materials, and membrane technology is now really dominating the world of the water desalination, but I think it will be even more important for many healthcare, biological applications, artificial organs, and so on. And of course, these days, we are, our membrane technology for water desalination is already really almost at the pinnacle of the possible state. We have unbelievably efficient membranes, and it's been the result of very heavy studies both in science and technology over the last, well, actually several decades, and that's the reason that we can successfully use this technology for water desalination, water treatment in Israel, I'm sure, and then will tell us much more about this, but also in Singapore. And I think, but there is still a way for improvement, and material science offers a number of solutions, and I'm happy that I think we can talk about this today.
Thank you. And then Professor Shechtman, you received the Nobel Prize in Chemistry in 2011 for your research on quasi-crystal. And you are now very interested in water, for instance, in desalination technologies. Am I right?
Right.
Okay, so will you tell us your ideas for water management?
Okay, I come from Israel, which is basically a dry country. The whole region of the Middle East is dry, and it has water issues that were there for generations. In the Middle East, there are three large rivers that go from Turkey down to Iraq and Syria on the one hand, and the Great Nile that flows from the south to the north in Egypt. Other than that, there are very small sources of water. And in my country, from the very beginning, it was clear that if we want to develop the country, we will need to distribute the water that we have, and later on to produce water from the sea. So from the very beginning, which is almost 100 years ago, the north of Israel has water, and the Sea of Galilee is a reservoir of water, and we started to transfer by huge pipes the water from the north to the south to push the desert further and further and further, and to produce food, which is vegetables and fruits and some basic food too. That was the beginning. And then we realized that we have to save water, and that required quite innovative thinking. And a good colleague of mine developed drip irrigation. Drip irrigation is a system by which every plant received the number of water drops that it needs. Every plant, only where the plant is, there is a few drops of water, exactly what the plant needs. If it needs fertilizer, it comes with the water. This is called drip irrigation, invented in Israel, spread all over the world. This saves a lot of water compared to flood irrigation, which is a horrible way or horrible waste of water that is used in certain parts of the world. In the recent stage, we realized that we have to desalinate water in Israel. And now, most of the water that we use in the country is desalinated for drinking, and home use is desalinated, and also for some agricultural use. In 2 years from now, we will have a production desalination of 1 billion cubic meters per year. So much so that water in Israel became a commodity that we sell. We sell Jordan 100 million cubic meters per year, and they pay the price for it, as we do too. Water is expensive. We pay a lot of money for the water, but we can afford it. This is the desalination, and this is the trend in the world. Water will be desalinated. What's nice about it is that all you need, besides the infrastructure, is electricity. And in many parts of the world that are basically dry, there is a lot of sunshine, and sunshine means electricity. So in parts of the world like the Atlantic Ocean of Morocco, you can make it a flourishing garden because you have sunlight, which means electricity, and you have the ocean, which means you can desalinate a lot of water and make a place which is now a desert, make it a garden. So this is the trend. Sun, electricity by the sun, and desalination. They go together, and it can change the world. It can produce food in an amount that it never existed before.
Okay, thanks. And then Professor Takeuchi, you have an experience of teaching at l'École nationale des ponts et chaussées in Paris. And what do you think about the importance of water in urban design or society design?
I see. Okay, firstly, I want to emphasize the importance of the difference between administrative political unit and water-based community. Because water-based community is nothing to do with political unit, and they have a very common interest in terms of the river and supply of drinking water and the sewage systems. And they have very important water station and for treatment. And then the most important thing is how to relate the deterioration or depreciation of facility or technology to pay for the future investment. And then all the cost must be redistributed to industry users and household. And this is a huge calculation issues. In the beginning, this charging system was established to make sure that drinking water was really reached to each household. But nowadays, I think the main concerns must be much more upgraded in terms of the security of water and also pollution issues. And somehow the terrorism issues or virus issues. So the technology must be much more complicated. And who will pay for that kind of renewal costs of the facilities? So the investment is not once. We have to really monitor all the duration of the facilities or machines or that kind of things to monitor and to, in terms of risk assessment. Because this risk assessment is much more related to the asset of individual of the household or buildings. So if there is a deterioration of the quality of water, that means all the area will be affected by those risks. Therefore, we have to really think about water management and relate to the cost side and investment side, and establish new type of complex business model to pay back that pay for the future generation. That I have learned. So economics and technology and scientists must work together, and then to cope with the shortened deterioration of facilities.
Thank you so much for pointing out the link between the water management and society. So let us move on to the second round. So do you have any questions to the comments by other panelists? Professor Oguma first.
Me first, okay. Well, I've just been thinking about innovations in my field of study, which is apparently the UV light emitting diodes, which was based on the innovation of the Professor Hiroshi Amano, the Nobel Prize laureate. And when I'm trying to use those innovative technologies to water treatment, I always feel like the cost and those financial issues could be an issue to apply that technology and innovation to the real world. And in my context, as I'm working a lot on the public health issues through water, the people that I really want to deliver those technologies are mostly based in developing countries. Still, those innovations are not really very much affordable for most of them. So I just would love to have some comments from any of you about how to implement those really innovative technologies to the places that are still in a developing stage.
Maybe I can,
Yeah.
I can start to answer Oguma-san's question.
Yeah.
So of course, we were saying that our membrane technology for water desalination works great, but still there are some level of improvement. And actually, what we learned in the previous session from Peter on aquaporin, so we're trying to learn from nature and develop novel materials for those membranes for desalination, but also for cleaning of the water. And smart membranes, those which can heal themselves, those which can clean themselves, would be on high demand in the future, because it just eradicates the need of the further treatment of water. And I suspect that membranes which can trigger and which can detect the presence of toxic species, whether biological, as you were discussing, or non-biological, would be a very interesting approach. And there are such technologies being developed already, so membranes which can be fully open when clean water comes, and only you need to remove salt, or would just close by themselves, triggered by the presence of some toxic species. I haven't seen the result on the presence of the biological species like bacteria, but I'm sure that it would be possible to do. So, and I think that the more of the solution we push on the material side, which basically doesn't require that much energy, so that we can make the more we can make our solution energy efficient.
One question.
Any answers? Dan?
About innovation. I'd like to talk a little bit about what does it take to innovate in water or any other field. It takes, first of all, knowledge. Innovators need to know what's available, what's happening. These are basically scientists and engineers in the subject that we are dealing with. Number two, top-down doesn't work. If somebody is giving an order, you have to develop it, he will not think out of the box, or he or she will not think out of the box. So they must be free to think. Number three, communication between the innovators and the decision makers. Not through the hierarchical levels, but direct communication. I know that in some societies this is very difficult to do. In my country, this is very common, that a bench engineer can reach the decision makers directly and talk to him or her about an idea. This direct communication is also very important. One more thing. It is best to develop things by communicating with colleagues, by knowing what's happening around the world. Scientists do not work alone. We go to conferences, and here is one example. We hear other scientists, and we discuss with them ideas, and this communication is also extremely important for innovation. So let's sum up. Number one, knowledge. Number two, communication across between the idea maker, the man with the idea, or the woman, and the decision makers, and collaboration, communication among scientists, among engineers. And then, by talking to people, by communicating this level and this level, ideas come up, but no top-down. You cannot give orders to somebody to innovate. It has to be bottoms up. The man or the woman with the idea should talk to the decision maker and say, I have an idea. Let's develop it. That's the way it works.
Thank you. So, okay?
Yes. Firstly, I want to emphasize that the water treatment systems, which is fortunately, it is quite universal character in terms of management and charging system, because it is thanks to kind of French or German models and in terms of regional management. And I visited China, Vietnam, Philippines, all those things. And I visited many water treatment stations. And still, they have very good level of engineers to keep and maintain that facilities. This is a lucky aspect. And the business models are also quite similar, thanks to the World Bank staff or international organizations. But the question is not here, in the future. How to renovate this kind of group of engineers working on site or even in the developing countries. They have installed quite nice research team as well. And then the level also quite high. And therefore, I think we have to reutilize the database or quality of membranes and when it was installed and what was the duration of the rest of the facilities. And all those kind of things we have to monitor. And the second thing is the value of money is different between the developing country and developing countries, and purchasing power is different. So how to really reinforce to buy the repurchase of high technology or membranes, and we need a kind of cooperation, very concrete type of cooperation in terms of financial matters. And we have to be aware of this, how to say, the universal aspect of water treatment. And also, as far as I know, the scarcity of water, groundwater changing, water situation because of climate change. We have to share certain destiny or a certain capacity to reinforce and equalize the opportunity for developed countries and developing countries. And in case we have to pay extra money, or if possible, I cannot say that yes, but once we know the real database and information, we can renew the business model or worldwide and share the costs.
Okay.
And let me maybe just jump in and answer a little bit to Takeuchi-san and Oguma-san. So I'll be brief. So why do we need the water treatment altogether? So we just want to make it safe, of course, right, for everyone, and of course, and because of that, we sterilize all the water which we use. But in fact, we probably need only to sterilize the water which we use in our food. So yeah. we sterilize so much water which we basically waste then for nothing. And it just is the general trend for the society. Okay, we just make the environment so safe, so people don't need to think. Maybe we just need to readjust our strategy. Maybe we need to educate people to think more about water, and then you can, for example, to water treat only the water which you drink. So you take away your huge UV plants from the central water supply and put smaller ones on people's tap. So it would save a hell lot of energy, but it would, of course, require people education. But I think investing into education is the best investment anyway.
Great. Yeah, thank you so much.
Any comments?
Oh, you want to say something?
I can make 2 comments from my own experience. In my university, I started many years ago, 35 years ago, a class which was called Technological Entrepreneurship. It means how to open a startup and succeed in it in the first trial. A very successful class. It was the largest class in my university for many years, and it's still running 35 years from the beginning. In a few years ago, we made a study what happened to the graduates, and the number of graduates, because my class had 600 students in my class every week, we did a little study to find out what happened with the graduates. So it's about more than 10,000 graduates from my class, and all of them are engineers and scientists. Turns out that 25% of them, 25% of these 10,000 people and more were involved in startups. So you can teach how to do that. But when you teach how to open a startup, you teach how to innovate. This is the thing. A startup is innovation. This is number 1. Number 2, every society needs more engineers and scientists. But how can you convince young people that engineering and science is better than being a lawyer and an accountant? How do you convince young people? My answer was, start teaching science early. How early? The mayor of my city asked me on the phone. I said, start teaching science in kindergartens. He said, will you do it in Haifa, my hometown? I said, do you pay? He said, I will pay. And we did it. And so now we teach in about 60 kindergartens science, real science. But it's not only the knowledge, it's the way of thinking. Be critical, ask questions. Why do you say that? I need to understand. And we teach very young people how to do that. We teach them to think logically so that people cannot push in their heads nonsense. Think logically, think critically. We teach it from a very early age. I recommend every country to copy it. I talk a lot about it around the world, and our countries send delegations to see how we do it in Israel. It has an effect. So, to sum up, number 1, you cannot teach how to innovate, but you can create a situation in which people are more encouraged to innovate, and they can do that. And number 2, education of science from a very early age. Make science understood by young people. They can think then logically, they can think then critically. And these are the modern, the new, the innovators of the future.
Okay, so
yes, one idea can be innovative. I'm not sure, but we have, in terms of emission or distribution of information about water, we have hazard map normally for earthquake or river issues, but we do not have kind of regional mapping or spotting or how your water come from where. And then we do not have where is a water station or treatment station. It's a very little information about it, because we just all rely on just the local authority to care. And instead of hazard map, why we don't have that water resource map, and then to distinguish where is the supply of water from river or from the mountain, and then switch system, how the water will go to up to the sea. And then I think that to increase awareness of the scarcity of water, I think maybe it's a good idea to ask that private company or treatment company to create kind of regional map and to aware the scarcity of groundwater or mountainous water. And instead of just buying mineral water, the bottled water, because we rely on tapped water every day. That's it.
Okay, thanks. So I enjoyed that talk, but the time is up. So we received a lot of examples in our session to state that the cutting-edge technology should collaborate with society. For example, education, collaboration, not top-down process, and so on. So Professor Oki stated in the morning talk that natural science has a tendency to exclude the human activities, but for the water management, we have to collaborate. Coupling science, technology, and human activities, and the collaboration between cutting edge and society. So thank you so much. Thank you so much for the audience.